is Paula Hill. I am the Math Specialist in Hazlehurst City School District. The focus of this video today is to model explicit instruction in the classroom. Before we begin, we must understand the meaning of explicit instruction. Explicit instruction is simply the I do and the we do of the lesson. The goals for providing explicit instruction is to teach scholars to enjoy and be competent in reading, writing, and math, to understand what they read and how math works, and to apply their skills in meaningful ways. During explicit instruction, the teacher should monitor the scholar's understanding and provide the kind of scaffolding throughout the learning process. Teacher clarity, enthusiasm, and the appropriate rate of the presentation are key variables in presenting explicit instruction. Scholars must be active participants in the learning process for explicit instruction to be effective. At this point, I will present a lesson plan that effectively demonstrates explicit instruction. Explicit instruction. These are the 8 mathematical practices. There must be evidence of the 8 mathematical practices throughout your lesson. You will not use all 8 in one lesson. As I use the mathematical practice throughout the lesson, I will refer to it. Bloom's taxonomy. There must also be evidence of Bloom's taxonomy. I have created questions using Bloom's taxonomy throughout the lesson. I will refer to these in the lesson. So let us start the lesson. After greeting scholars at the door, students will know that the bell ringer is on the board and they should be ready to learn because you have set your expectations of the class from the beginning of school. Scholars should have 5 minutes to finish the bell ringer. The bell ringer should come from a previous lesson or introducing them to today's lesson. My recommendations is that the bell ringer should be a question of a standard that has not been mastered. After time is up, you should give the answer to the bell ringer. Asking scholars to give you a thumbs up or down next to their chest. This will give you an idea of an individual scholar's understanding. Asking a scholar to come to the board and explain the problem will give other students a chance to hear from another peer as how they work the problem. A lot of times a peer will give them a clearer explanation of the problem better than what you as a teacher can give them. After the scholar has worked the problem, other scholars may have seen the problem in a different way but got the same answer. This will be open for discussion. This method of working and going over the bell ringer lends itself to allow students to construct viable arguments and critique the reasoning of others, which is mathematical practice 3. The teacher should then give test-taking strategies for answering the question. Some type of accountability should be assigned to the bell ringer. Sprints are a good way to practice fluency. 10 to 15 problems is enough for a sprint. Students love the sprints. You should only give them 1 minute to complete the sprint. After checking their answers, the teacher should ask the scholars by the raising of hands who got 1 right, 2 right, etc., until you get to the max number. This way all the scholars will be involved instead of who got the most right. Fluency does not really mean speed, but how many they got right. The teacher should review the previous lesson. This will set the stage for the learning process. The teacher should review vocabulary and problems. In mathematics, it is key that scholars talk the mathematic language. The scholars have a ring of mathematical vocabulary. The teacher should read the definition of the term, and the student should find the vocabulary word in their ring and hold it up. This will give the teacher a chance to see that the scholars have an understanding of the definition. The teacher may ask for the scholar to give an example. This is called locate. As I start the lesson, I will go over the standard or standards and the I can statements for that day's lesson, pointing out key terms. The teacher should explain to the scholar a clear explanation of what the scholar should be able to do at the end of the lesson. The scholar should be able to solve, check, and write a one-step equation. The teacher should write the essential question of the day on the board and refer back to it at the end of the lesson. When starting the lesson, new vocabulary words are introduced with examples. The teacher should remind the scholars of what a number sentence is by giving examples. Remind them that they are looking for an unknown, and that an unknown is represented with a variable instead of a blank. Notes that should be provided to the scholars are that when you solve an equation, you're solving to find the number that is missing. This missing number is usually shown as a letter. You have to find the number that is missing to solve the equation. The teacher should give the scholar an example of an equation, asking the scholars about the makeup of the equation. For example, what is the difference between an expression and an equation? Identifying the variable. What operation is it? What is the coefficient? What are the constants? The teacher should go through working 4 different one-step equations and giving them prompts on what the scholar should do next to solve the equation. Pointing out key vocabulary words. Use the river as the equal sign. As you are going through the problems, you could have the students write the equation in words and also producing a real-world scenario for the equations. Scholars will be asked to persevere with problems. This is mathematical practice 1. Mistakes are expected, respected, inspected, and corrected. Notice you can express a one-step equation in different ways. It does not change how you go about to solve the equation. The teacher needs to give the scholars an example of this. You should discuss the solution of the equation, how to check to determine if the solution will make the equation true. Question to ask the scholars is, the quotient of x and 5 equals 6. What value makes the sentence true? Is there only one solution? Give the scholars steps they can remember to solve one-step equation. Number 1, identify a variable in an equation. Their goal is to get the variable alone by itself on one side of the equation. In other words, you are trying to isolate the variable. Whenever you see a variable, it is understood to have a 1 in front of it. Whenever you see a negative sign in front of a number or variable, it is understood to have a negative 1 in front of the variable. What does it mean to have an equation with one variable on one side? Is a question you may ask the scholar. This shows comprehension. Number 2, what operation is it? You must use the inverse operations to isolate the variable on one side of the equation. Number 3, do the opposite operation to both sides. Whatever you do to one side of an equation, you must do to the other side of the equation. In other words, you must keep the equation equal and balanced. Number 4, write the answer. Number 5, check your answer. The teacher should use the balance scale. This will give them a concrete model on how the balance scale works. Scholars should think of solving an equation like lifting weights. If you add or subtract weight from one side of the barbell, you must add or subtract the same amount from the other side of the barbell to keep it balanced. Therefore, in solving a one-step equation, the same has to be done to balance the equation. If they add or subtract from one side of the equation, you must add or subtract the same number from the other side of the equation. In the same sense, the scholars need to recognize that if they multiply or divide from one side of the equation. They must multiply or divide the same number from the other side of the equation. It is very important that scholars pay close attention to the steps, signs, and equality in an equation, which is mathematical practice 6. A question you could ask the scholar: if I have the equation x plus 4 equals 6, what do we need to do to solve this problem? Write out your answers in words. Some scholars will start to see a pattern and do mental math to solve the problem. They will be able to determine shortcuts and patterns in reasoning, which is mathematical practice 7 and 8. But it is best that a scholar practice writing out the steps, because the next concept to be taught is solving two-step equations and multi-step equation. This is one example of writing equation. The scholar needs to know how to write equations in words. You should also give them real-world problems. Centers could be created for the you-do. Introducing algebra tiles to the scholars is a good hands-on activity. The following is an exercise that you could use in a group. Do not forget to assign homework for the scholars to practice. I tell my scholars that math is not to study, but to practice. It is at this time the teacher should come back with the I can statements and the essential question. An exit ticket should be given at the last 3 to 5 minutes of class and given to you as they leave class. Remember, the teacher dismisses the class, not the scholars. Here are some examples of an exit ticket. This is the end of this lesson plan. The most important aspect of explicit instruction is to plan. I cannot express it enough. As it has been said, failure to plan is planning to fail. I hope this video has and will be very beneficial in your classroom.